Thank you. This is me. I'm second year honors BSMS CSEC. I've done a couple presentations this year, so I feel like everybody in this room knows me. Um, but I'm local. I'm on CCDC with ASA. Um, I'm working at a small fruit company next summer. I'm on the club. Yeah, Orange Ink. I'm on the club volleyball team. I play a lot of sports, follower of Christ, and I'm a big fan of Chick-fil-A. So about this presentation, Will forced me into this against my will. All right, for real, he actually didn't. But this was spawned from a little red team tool that me and Danny wrote together. It's called Javalanche. And basically everybody gave us crap for it because we decided to write it in Java. And I guess not everybody likes Java as much as we do. So everybody's like, why are you writing red team tools in Java? That makes no sense. But there was a lot more that went into it besides just it's our favorite language, right? And so that's kind of what this presentation is going to be about. And later, a lot of those things and those decisions and our whole decision-making process was a big part of why I ended up getting hired at Apple. So this kind of presentation is going to be about that process and what the project taught us, mainly me, about learning different programming languages and using them in different projects. And it was a pretty cool experience. So this is just a little description of Javalanche. It's a red team tool. It's a C2 server. We use it so that one person can control many machines at one time. So how many people here have competed in an IRSEC or a red versus blue competition? Everybody's raising their hands. That's kind of cool. So everybody knows when you're in a comp and just a line of machines goes red at once, right? Not one team, but one type of machine all at once, right? We ran a break on HTTP server or Active Directory, right? This is how we do those types of things. We use C2 servers so that we can run one command on as many machines as we want. They're super helpful, super useful. Hi, Liz. um, and they're pretty helpful. They're pretty awesome. And this is a pretty cool one that we wrote and we put a lot of effort into. It's about 3,500 lines of code. We've put a lot of time into it. And it's pretty cool. So that's kind of just the diagram. And then these are all the languages we used. It is called Javalanche, but Java is one of 6 languages used at the moment. We're probably going to add more. And there's a lot of reasons why we chose different languages for everything we did, and that's what we're kind of going to talk about. So why did we make the decisions we did? This was a big part of the interview that I referenced earlier is, why did you choose this for this? Why did you choose this for this? And what was that process look like? And it actually had nothing to do with the language itself at the start. The whole thing was, what do we want to accomplish, right? If I'm writing a payload for Windows, what do I want it to accomplish, right? And at start, that is just executing a command, right? And as the project evolved, it became, oh wait, I want to execute a command. Now I want more persistence. Now I want more features that are available for me, right? So we're going to talk about later, the initial part of that was just, okay, I just needed to execute a command in PowerShell, so let's use a PowerShell script. Now we want more persistence. Now let's turn it into a service. We need to use Ansible to do the deployment for that, and we can use PowerShell for that. But later on, we want to add more things into it, right? So one thing that this does is it looks at your current, what is it called when you hit Control-C? Yeah, your clipboard, thank you. Thanks, Liz. Your clipboard, right? That's a Win API call. Little easier to do than just doing it in PowerShell, right? So we want to add more Win API calls, right? So that's a little example of that decision-making process of what do we want to do? Now what's the best option for what we want to do with it, right? Not what am I the best with, right? Because if I was just doing that, I would just write the whole thing in Python and Java, right? Because it's super simple. Python is super easy to use. If we wrote the whole thing in Python, it would be less than 1,000 lines, right? But we chose the hard way. The development process. Will said I should put this in here, but honestly, we didn't do a great job at the development process. We didn't start using branches until like a month ago. And a lot of our commit messages are interesting. And we definitely did not use Agile, Scrum. So the actual parts and why we chose the things that we did. So this is kind of interesting. Everybody, has anybody not taken 123 or 124 or 127? Right. Yeah, I think it's a, oh, okay. Sorry, Liz. So this is a required class, right? And the last project of 124, 127 is Tiny Chat, and it's basically like Discord in Java, and it's really cool. And it's meant to teach threading, multi-threaded server client, and it's really cool. And Javalanche is actually a fork of Tiny Chat. I took the code and I copy pasted it into the server and the proxy, and that's what we started with. And this was pretty cool because I really liked. Yes, Asa. Because it wasn't an actual fork. I just hit Control A, Control C, Control V. um, heavily took inspiration from. Um, which I thought was really cool because one thing that I like to do in my personal projects is take the stuff that we've learned in class and now you're implementing it in something that you're more passionate about instead of just I have to do this for an assignment. Right now I'm doing it because I want to and because I think it's cool and because I want to put it on my resume and I want to talk about it in an interview. So that's what we did with this. Love multi-threading servers and clients within Java. It's honestly my favorite thing. And that's why we chose Java, because handling threads is awesome. Yeah, so why did we choose Java? I'm kind of a neat freak. And so Java is so object oriented that I love it, right? Everything is an object and it's perfect for me because I can organize everything exactly how I want, right? And from there, you can organize all the threads exactly how you want. And we only started doing this later in the development, using threads correctly with waiting and notifying for the organization and for speeding everything up. Super helpful, also looks super good. And error handling with that, and just using the language and the benefits and the skills and what it provides to you for this exact scenario, right? The clients, there's no reason for the clients to be multi-threaded and to have these extra features, right? I don't need my Windows payload having 6 threads running to handle a bunch of different things, right? But my C2 server, it does, because I need to communicate it with it while it's also communicating with all my proxies, while it's also sending messages to pwn board so that we know what's going on, right? So that's kind of why we chose Java. Super cool. I think in the last slide, yeah, it's a lot of code, a lot of Java. Everybody gave us crap for it at the start because, you know, if we wrote it in Python, it would have been like 200 lines. But it's pretty cool and it works. So the Windows payloads. This is when we get into the payloads, we're going to see more of that, more development process and choosing languages because not because we're good and we like them, but because they're actually the best option, right? So the initial payload was written in PowerShell. Why? It's built into Windows, no dependencies. You can just run a PowerShell script on a machine, and you know you don't have to worry about. I mean, like there's modules that might not be installed, but you don't have to worry about having a runtime, like a just-in-time compiler or anything like you might with Java. So, right, that's what we want to do in PowerShell. It's super simple. It's like 50 lines of code or something. We were mainly using it for testing at first, right? So the disadvantages, though, it's not compiled, so someone can just like look at the payload itself and then they know exactly what it's doing. Compiling isn't actually obfuscating, but nobody's actually going to start reverse engineering a binary in like IRSEC or something. You don't have the time to do that. And then persisting of .ps1, a PowerShell script, isn't as good as an executable, because if you write an executable, you can actually write it as a service, and you can handle the calls to the service control manager, which we're going to see in a second. Yeah. So the new one we wrote in C++. Now, C++, I don't love it because I'm not that good at it, but this was also a fork from CSEC 201 assignment 4. It was there's like a server client you had to write in that class, and yeah, so we started as a fork from that, and then we just added command execution from it. C++ is good because you know we don't need extra libraries because it's Windows. This is the Windows payload. The Win API is good because it gives you very accurate control over everything you're doing. You can do a lot of very specific things, like we talked about earlier about accessing what people have in their clipboard, because you guys will put passwords in there often. And then it's compiled, And because it's C++, it's pretty easy to organize, like up there. I like my organization, right? So header files keep things organized and nice and neat, and there's not just a bunch of code in one file. The downsides, though, like it's really hard to write if you're not that good at it, and takes some time and a lot of scrolling on the Microsoft Learn documentation sometime. Like that's just way too many parameters for one function call, in my opinion. But this is the best option for a Windows payload because of all the things we've written, right? So like the downsides, yeah, it's gonna take me more time, but just because it takes more time doesn't mean I shouldn't do it, right? You wanna do the option that is the best suited for the problem you have. And now we're gonna see that even more with a Linux payload. I didn't know Bash, but I needed something to test like how we did with our initial PowerShell payload. So I learned Bash, wrote a simple Bash script to test to make sure that we could, have command execution and our servers were working correctly from a Linux machine. Disadvantages are basically the same thing as the Windows PowerShell script. It's not compiled, no obfuscation. Another really bad disadvantage to using Bash was that each Bash command has to work on each different Linux distribution. Now, this was a huge problem because Linux, right? Like, we were doing UB lockdown, and when I transitioned to just using static IP addresses I started using a domain, javalanche.net, and it would resolve the IP address of whatever beacon I was using. Ubuntu didn't have NSLOOKUP installed by default on all of their machines, right? So I just couldn't deploy to Linux for that competition because I didn't have time to like run apt install nettools or whatever it was, right? So that's like a problem you would see with just Linux distributions and trying to use a bash file. The fix to this was to write a new payload in Go. Go is not only compiled, it is maintained by Google. That's why it's called Go. And that is the actual mascot. I thought that was super cute while I was making this. But you can compile it for a bunch of different distributions without actually changing the code itself, which is awesome because you just need to change the command you're running to change the compilation of the binary. So I can write one command or one file and compile it for all of these different distributions, and it'll work perfectly on them without any having to install any libraries or anything. Super awesome, super helpful. Only took, and like a downside of this was I didn't know Go, and we had a comp the next day. It was UB High School, and I learned Go at 5 o'clock the night before, and I wrote a new payload, and it worked until it didn't. But we don't have to worry about that. And also, something I would recommend: don't use chat to write your code. This is something me and Leah joke around about. There's using chat. There's using chat and then fixing the code, and then there's just writing your own code and learning it yourself from Stack Overflow or W3 schools. 10 times better. This whole payload didn't even ask chat a single thing. That's how I like to code, and I think it's a lot better than if you're actually going to use chat for anything. Server deployment. This is another big tool that we had to use. Saves us a lot of time from doing it manually. We just needed simple scripts to download files and to compile Java, which isn't actually as easy as you would think if you've never done it for the first time. You actually have to do a few things before you can just run java.exe and then your server, right? So writing out scripts to actually get all of our files, install Java if it wasn't already available. But why use PowerShell and Bash? Because these are super simple, and we don't need to write a full-on executable for everything. There's no obfuscation needed. It's just deploying our server, right? So Bash and PowerShell are perfect for this. And then payload. Payloads are deployed with Ansible. This is because Ansible is kind of used for everything red team-wise for deployment, and it fit in better than any other solution I would have used. There wasn't much thought that had to go into this. There's been a half dozen research presentations and education presentations on Ansible. So if you want to learn more on those, you can. It's a remote deployment mechanism. Uses SSH for Linux, WinRM on Windows. Really simple, really easy to learn. Only took like an hour for me from never using Ansible before to being able to deploy to as many machines as I wanted. So yeah, I think that's it. If anyone has any questions. This was thrown together yesterday after Will had someone back out. Yes, Asa. How could this be used defensively? So, imagine this. We let a fourth-year CSEC student on 2 machines in CCDC, and he just so happens to lock himself out of both of the boxes. I'm not looking at anyone in the room right now. But if he were to happen to lock himself out of both of the machines, you would be able to deploy this before he did that to make sure you could get back into your own machines. I don't know, maybe I'll work on ASA proofing the Windows payload. Thank you.